Alright, one last example from section 2.3. So this is an example of how you would apply the squeeze theorem. So here we want to find the limit as x goes to 0 of x to the fourth times the cosine of 2 over x. So, direct substitution will cause some problems because we have division by 0 inside of the argument of cosine. So we're going to use the squeeze theorem. So the idea of the squeeze theorem is that if you can bound kind of your unknown with two different functions, okay, so suppose we bound something with the absolute value of x and minus the absolute value of x here. So minus the absolute value of x is this upside down v. And whatever we have, whatever function we have that we don't know the limit of, that's trapped inside. Okay, so it's trapped between an upper bound and a lower bound. If we can find the limits of the upper and lower bound at a given point, we can actually squeeze the middle function and find the limit of that function at that point. So that's why it's called the squeeze theorem. So let's see how it works. So I know something about cosine as well as sine. Okay, the range of sine and cosine goes between -1 and 1. So I can always bound cosine of whatever it happens to have as an argument as being less than or equal to 1 and greater than or equal to -1. Okay, that's always going to be true. I also know that x to the fourth is always a positive quantity, or greater than or equal to 0. So whether I have a negative number raised to the fourth power or a positive number raised to the fourth power, it's always a positive quantity. So if I go ahead and multiply all three of these pieces of my inequality by x to the fourth, it's not going to cause any of the inequalities to flip. Okay? So I'm going to go ahead and do that. So that would give me minus x to the fourth less than or equal to x to the fourth cosine of 2 over x less than or equal to x to the fourth. So hopefully you can see this middle guy is exactly the limit that we're trying to evaluate, that we can't just directly take the limit of. But in doing these bounds, we've created an upper bound of x to the fourth and a lower bound of minus x to the fourth. And those are actually pretty easy limits to take. Okay, so let's take the limit of the lower bound first. Okay, so the limit as x goes to 0 of minus x to the fourth. There's nothing wrong with using direct substitution here, so we just get 0. Likewise, the limit of the upper bound, limit as x goes to 0 of x to the fourth, is also equal to 0. So let me draw that graphically. So I'm going to go to the next page here. Okay, here's a graph. I'll remind myself of something. Okay, so here's our lower bound function. Minus x to the fourth. Here is our upper bound function. Okay. Because I was able to create that inequality, that means that x to the fourth times the cosine of 2 over x is always lying in between these two graphs. Okay? So since we found that at 0, both the upper bound and lower bound are also going to 0, there's nothing else for the middle graph to do but to also go to 0. So we can go ahead and say that the limit as x goes to 4 of x to the fourth times the cosine of 2 over x is equal to 0. I'm going to say by the squeeze theorem. Okay, so on an exam, on a written exam, I will expect you to quote whenever you use a theorem. So make sure that you show all of your work similar to what I've just laid out here, and you quote all theorems that you use as part of your solution. Okay, so hopefully that clears up some questions. Good luck with the homework. Let me know if you have more questions.